Hello everyone, this is lecture 78 of Principles of Electric Circuits. We discuss a dot convention. With dot convention, we can solve the question introduced at the end of the lecture 77. After having the mutual inductance, if without any restrictions, we must draw the winding directions of the two coils so as to determine the induced voltage on a coil according to the current of another coil. Let's review the question presented in the last part of the last lecture. You see, if we only consider the induced voltage of coil 2 produced by the current of coil 1, so under the winding direction of the first figure, if the secondary voltage is positive above and negative below, then we have positive M di1 over dt, but for the second figure, that is negative M di1 over dt. In order to not to draw the winding direction of the coils in practice, we must have label. Let's look at the second figure. MU21 equals minus M di1 over dt. Does it mean if we label the voltage direction of the port 2 as negative above and positive below, then U equals M di1 over dt? You might as well think about it. The voltage labeled in the second figure and the voltage labeled in the first figure all make the mutual voltage M di1 over dt. What are the similarities between these two? You see, generally, both two coupling coils will have currents when working. That is to say, the current of I1 coil 1 will induce voltage on coil 2, and the current of coil 2 will also induce voltage on coil 1. If the current of the coil 2 flows into the positive label of the voltage, then its magnetic field and the one generated by coil 1 are enhanced superposition. Under such reference directions, if the current of coil 2 flows into the positive label of the voltage likewise, its magnetic field and the one generated by the current of coil 1 are enhanced superposition. It gives us a very important enlightenment. That is to say, for two coupling coils, if their current directions make the magnetic field enhanced, we can define the positive of the voltage as a terminal flowing into the current so that the induced voltage is positive mdi over dt. So there is a concept of the dot convention. The definition of the dot convention is stated as follows. For two mutual inductors, there is one dot on one terminal for each coil. If the currents of the two coils flow into the dots, the total magnetic field is enhanced. We call these two dots the dot convention. You see, if we think that the current of the first coil flow into from here, we might as well mark it as a star. The direction of the magnetic field is like this, so the current of the second coil must flow from here so as to produce the same direction of the magnetic field. So here the two stars constitute the dot convention of the two coils. However, it should be noted that, of course, we can mark these two terminals as dot convention, but similarly, we can also mark these two terminals as a dot convention. Because they produce the same direction of the magnetic field, they are all downward. So there is a very important point about the dot convention, that is the dot convention of the two coils need to be determined together. In other words, the dot convention of the two coils can be determined arbitrarily, but once you determine one dot for one coil, another dot for another coil is also determined. Next, let's look at the case that another coil is reversed. We can assume that here is a dot, so the magnetic field direction is like this. For the second coil, it needs to be set a dot here, so as to make the magnetic field direction upward. Similarly, we can mark here and here as a dot convention, whose magnetic field directions are all downward. Well, now we do an exercise. We assume that the magnetic field only flow in the box due to the magnetic medium without flowing to the outside. We might as well set this terminal as a dot, so the magnetic field in the magnetic medium is clockwise. So for the second coil, it must set here as a dot. The dot convention includes one terminal of each coil for two coils, but in the presence of three or more coils, there are dot convention between any two. We might as well have a look. Now we discuss N1 and N2. the direction of the magnetic field has been given in the figure, it means that the dot should be like this for N1. The related dot for coil N2 should be like this. If we consider N1 and N3, then it should be like this. If we consider N2 and N3, it should be like this. Did you find? For the three coils, of course, it should have three groups of dot conventions, but if we can determine the third group according to the other two groups, we can use 3 dots instead of 6 dots. That is to say, we think these 3 terminals are the dot convention of the 3 coils.